Okay, so what I've done on my system is, I'll just show you the preparation of it. I have created an Anaconda environment, which I called Azure ML. You can actually create these environments into your pure Python also, but why Anaconda is recommended in case if you're using Azure MLs, because most of the Azure MLs, you can say images where the deployment happens are based upon Miniconda. So Miniconda is a very scaled down version of Anaconda. It gives you all the environments similar binaries. The only thing is that it's not loaded with a lot of Python libraries that come preloaded with Anaconda. So Anaconda comes preloaded with hundreds of Python libraries, and if you were to make an image which is completely based on Anaconda distribution, that will have the image. So to avoid that, most of the deployment images are based upon Miniconda. The advantage that that gives is you can have like Anaconda packages directly being working on those things, and Anaconda packages are slightly better than in some of the cases your pure Python or PyPy packages, because those are tested for a lot of security related issues, and they are pre-built for different types of environments which they are targeted to. So they speed up both in terms of your creation of the environment and also to some extent the execution of the code by being purpose built for those particular environment. And also in some of the cases they might have some security vulnerabilities also covered into it. And that is why when we'll actually see the creation of the environment part in Azure, instead of using like a plain requirements.txt which covers mostly PyPy based requirements, it will have actually two types of requirements. One will be a Conda requirements for any packages that there is pre-built in Anaconda, you can directly use over there. And if there's some packages that you're getting from PyPy and not from Conda, you can have like different set of requirements being mentioned over there. In this Azure ML packages, this has just a SDK, the Python SDK of Azure ML. And it is very highly recommended that you actually create a different environment for it, because Azure ML requires very for example, scikit packages or NumPy and any of the common dependencies that you might be using in any of the earlier environments also you have, and there might be a chance that you are clashing with that. You just create a different environment for it, and within that environment you can run any of your Anaconda ways or notebooks. So this notebook I'm actually running within this particular environment, and I showed you config.json. So once you actually download that config.json, it will look something like this. It will have a subscription ID, which is the subscription key that we actually showed you. It is the ID for that particular key. Your resource group under which this workshop comes, and your workshop name. Okay, so this is the basic config.json that will be had downloaded from the workspace as we showed. This is the only thing that you require to authenticate that local Jupyter. If you are on a cloud-based Jupyter, which is directly within your workspace, even that authentication at times is not required. You can just directly get started. And if you're working on locally, this is the only thing that you require at the bare minimum to get started with authenticating your specific Jupyter instance that you're working on with your workspace. And anything that you do from here onwards on this Jupyter, any Python SDK, Azure ML SDK that you invoke would actually be connected to that workspace. Now this is, so what I've done is slightly more advanced way of authentication, because my intention is not to just authenticate my Jupyter, but also any of the REST services that I create, I should be able to use it from there. So what I've done is I actually have registered an application, and I have got for that particular the application ID and password. We'll be covering the creation of this application also later, and I'll be using this way of authenticating by both my Jupyter and my REST services. In this particular session, we'll just take some data, and I'll just explain some data all there. We'll create a model, a prediction model on the data, and we will host that model as a service using Azure Containers Instances. So we'll be having a container which will host a REST service, and when I say host a REST service, what it will do internally is it will convert it first into a Flask application automatically without me knowing it. So I'll not cover any of the Flask code. I'll just have a very small script that you do not require to know anything on the engineering side of it. As a data scientist, you can create that particular script. Internally, it will expose it as a Flask service. That Flask will actually get deployed into a GUnicorn WSGI. So how you deploy a Python code or Python services through a web service gateway interface. Using a Flask directly to deploy it is not a very good practice for production. So what it will do is it will actually create a GUnicorn based WSGI for it, and then it will be deploying those Flask services with WSGI into a container But all these things would actually be transparent for me. I'll not be seeing these things. I'll be just writing 2 pieces of code, and automatically the things will be done at its own end. So the first thing that I'll be doing over here is to authenticate my workspace. And to authenticate my workspace, the one that I showed you in terms of the application, that is what I'll be using. So I'll be calling my workspace, number one, such that I know which workspace I'm dealing with. In this particular case, the workspace that I showed is that is the one. And my authentication way is just service principal authentication, which is an app-based authentication. I've created an app within Azure to do that. And the only thing that I required is my subscription ID, my workspace name, resource group, and that application ID and the secret of it. This code is still executing. Once you have executed this code, it will actually give you that you are connected from the workspace. Okay, so now we are authenticated to the workspace, and we have got the message that the workspace that we're talking about is found in this particular location. And from here onwards, we can go ahead. In case if there's any problem over here, I also left troubleshooting space. You can actually troubleshoot what are different workspaces that you have, or what are different subscriptions, and you can connect to that particular subscriptions. Most of the times, subscription related issues that workspaces are not found or couldn't be authenticated. Now from here onwards, it's like a normal Python code. I'll just show you the data that I'm going to use. So it's a diabetes data. So what it does is it uses different factors, features for a particular person's primary diagnostics in terms of the questions or the blood test reports that you might get to detect if how much is the risk of you say diabetes, and it gives like a binary prediction whether it's a 0 or 1, and if the prediction is 1, which means that the person is very likely to be diabetic and advanced procedures need to be carried for that particular person. So up till here, from pregnancies to say age are our features, and this diabetic is y value or the type of things that we are trying to predict over here. Although I've called two of the Azure SDK classes, which is the experiment and model, and this reflects to the same experiment and model that we covered earlier in terms of what we showed in the workspace. There were two tabs like experiment and model, and we showed that these are the child elements within a particular workspace. So now, since we are authenticated with that particular workspace, any experiment or model that we actually call would be a part of the particular workspace that we are authenticated with. So in the initial part, we'll be using only sklearn or scikit-learn and normal Python codes, and only for registering models, we'll be using these two things. So the code up till here just creates a very basic model. This in no sense is like a very sophisticated models, and I have actually put a lot of link to some of towards data science pages that I found, which has a more comprehensive treatment of for the same data set in terms of diagnostics. But this session is not towards the ML part of creating the models and what all things you need to do for the pre-processing for creating the models, etc. It's more focused towards how do you work with the Azure ML in terms of model building and deployment. So I've kept the model training part relatively short. I'll just take the model and without any, you can say, pre-processing, will directly split it into test and training groups and start building the model. So this model that we are using are decision tree classifier, and in fact within sklearn, scikit-learn, if you use any types of classifier, you will have like a similar way that you'll deploy this particular model. So my environment there would be scikit-learn environment, and there are two ways that I could do it. One is a environment specific estimator in Azure, and these estimators come into question only when I'm using an Azure based model training. In this particular case, I'm using a local model training, in which case I do not even require to tell as of now what type of model it is. But if I were to use the same script and train a model internally with using all the resources that Azure provides me, I'll either use the scikit-learn based estimator or a generic estimator and give it scikit-learn dependencies over there. Okay, and this is the standard way that you actually predict and evaluate a model. So here we are using accuracies and the area under the curve for AUC statistics. And up till here, I have not used any of the Azure SDKs right now for making my models. This is a completely local model that you can build directly on your system without even having Azure installed. Once you have the training completed, what you will find actually is in this tab, you will have a training model that will come out, which will be a diabetes model dactyl. And anything related to Azure for us would actually start from there, where we will consider now we have a model being trained by any of the machine learning methods that we would have used to train that particular model, and then we will deploy that model on Azure. So we have got the model, the training has been done, we have got the accuracy and AUC reported over there. Since I'm dealing it as a local model, I have not even uploaded these results into my Azure. But once you are actually training the model in a similar way, even if you are training the model locally, but if you are training using Azure services and APIs to train that particular model, then you can even upload these statistics with the model onto Azure, in which case you can just see for each of these training runs, what are the different models available, what has been the accuracy of each of these models. So if you want to roll back to a particular version of the model, you can say that this version had a higher accuracy or this version has a higher AUC, and that is why I'm actually rolling back to a previous version of the model. So even after training it locally also, I can upload these with those things, and that is what I will be showing later. So first, what I need to do is, before I register a particular model with Azure, I need to upload this model file over there. If I am running this particular code in a VM within my workspace, step is not required, because in that particular case, these models are actually stored within data store or blob storage within the workspace. And since the blob storage is already registered with the workspace, it can directly pick the model from there. But in this particular case, since Azure doesn't even know about this model, I first uploaded it in a particular, I have not even specified where I'm uploading that, except for the path, and it already has a data store inbuilt. So the moment I create a particular workspace, Azure creates a data store with that, and any path that I'm giving for uploading any of the files get into that particular data store. So this is how that easy it is with creating a workspace. Now I'm calling run.complete for the simple reason that all these trainings of the models and uploading of the models are asynchronous process, which expedites the training a lot, and you can actually keep doing some of the other tasks that doesn't requires the trained model to be used without actually keeping you waiting in a synchronous loop. But there might be some steps that might be required that could happen only after the model is trained and uploaded, and that is where this run.complete merges the synchronous back to the synchronous wait. So now when the model is there, okay, let's actually go to back to our Azure and see if the model is actually there. Right now, this model is in just a pickle format, and Azure Workspace doesn't know if it's actually a model or if it's something else and how it's supposed to use that particular model. So now we'll register this pickle file that we have got as a model, and that is where that model class comes into picture. And by doing so, we can just tell Azure that this was the accuracy for it, so that we can do a similar things on versioning control based on accuracies earlier. That would have we would have done had we trained this model directly on Azure. So this step is running. So we have got a model uploaded onto the Azure space, and then we are just seeing if the model exists, and if the model exists, we will just register it over there. The same diabetes model that we have, now we have got 5 versions of it. And if we go inside any of these versions, you can see the details of it. So these are the details of this particular model. Now if you see over here, launch the studio preview. So this actually gives more information and more, you can say, enriching information about the different types of deployment that you can compare the models with in terms of the statistics that they have actually shown. So this is the previous version of the workspace, and this is machine learning studio. And in this particular case, I have not deployed this model, so it's not showing any deployments. But if I have like multiple versions of my model and each version is deployed separately, for example, it may so happen that I've made an application and application version is actually using a particular model. I just do not want to refresh the model within that particular application version. For example, suppose if I want to do a A/B testing, so I have one model which is making some predictions. So I've deployed other models. But now, actually, in any of the enterprise applications, will not just change the models directly. You'll have like gradually introduce the new model. You'll see how it is behaving on real data, and then slowly you will actually scale down the previous model and get to the new model. So if you want to actually have, you can have multiple versions of the model being deployed, and that is why deployment here is actually a step within the model version and not on the model as a whole, because you can deploy multiple versions of the model and get like a different URIs for those versions. So once you actually do that, and if you call this particular model version, so if you saw over there, we had 5 versions of models, and for each of these versions, it is now showing me what are the different accuracies and AUCs. In this particular case, these are the same training data that I've used, and I've trained the same deterministic model. So you are seeing the same AUC and accuracy curves. The moment I change some parameters in the model, or I actually change some things in the data, these things, AUC and accuracies, might actually change in those different versions of the model. I'll assume that this is a different notebook and not the same notebook. If I want to deploy it, I can actually have a different notebooks and do it. And the way that I'll do is I'll first call the models that are exist in my workspace. already had the model already instantiated, I could have used the same model here and actually used it within here from my workspace that when I uploaded that particular thing. From the run, I could have got the model. I'm uploading this, and from that run, I could have got the model. But assuming that you can actually do it in two different workspokes where the run part is different from the deployment part, you can get the model from the workspace. So although model was part of the run when it was generated, but as we showed in this workspace, irrespective of which run generated a model is actually becomes a part of the workspace. So I can generate the model from the run if I have the run instance with me in the code alive. Otherwise, I can generate the model actually from the workspace itself. So this is what I'm doing over here. From the workspace, I'm calling the model with the model name. It has different versions, so it will show me which is the latest version. So in this particular case, version is 5. Latest version is 5. I can call any other specific version also, but in this particular case, I am using the latest version. Now things start getting interested in terms of deployment. Now my intention is to deploy this particular model, and to deploy this, obviously you require a scoring script. So Python would not know, or any service would not know how to use that model. So I have to tell them, okay, this is the input that you're expecting. You're expecting those 5 features that we talked about. So in this particular case, you're expecting these pregnancies, plasma, not by the name, but at least you're expecting 1, 2, 3, 4, 5, 6, 7 features, 8 features, and this is the output. And in case if I'm doing any pre-processing step, for example, if I'm scaling say plasma glucose between 0 to 1, I'm scaling my BMI between say -1 to 1. All these pre-processing that you want to do, you will actually do in your inference scripts also. What we'll do as an inference script is I'll delete this folder that has my previous model being deployed, and I'll create a new folder over here. So what we'll do is it will write this file into my new folder. This is my scoring script. In the scoring script, I have done very minimal work. I have done declared just 2 functions. One is my init function. Init function comes into picture whenever your model is instantiated, or your web service is instantiated. So for example, the first time the container is started, it will draw this model, or it will extract this model from my workspace. The same way that I extracted the model over here just to show you. Now this container that I'll be erecting, it will actually get this model from my workspace, and container would be deployed inside the workspace, so it will actually not require any of the authentication if it is within my workspace to get this particular model. It knows that this is the same workspace that the model is there from which it is running. So this is the only one step that I'll be doing from in the init work, because I do not want the model to be loading every time a new request is come, because that's a static work. Then I'll have another function called run. Now these function names are reserved, so anything that you're doing with Azure ML in terms of deployment script, these have specific features, how these models or how these functions are actually treated within Azure. So do not use these for any other functions that you want to use. All the helper function that you want to create within your scoring script, you can create by any other name, or you can actually have them bundled within the same folder. You can have your all the utils files within the same folder that will be creating, and that whole folder, the whole folder that will be writing this to, this folder name, that folder will come up over here. You can write any of the utils file over there, and those will be actually ported in the container that it will be making. So it has now created a blank folder services for me. Okay, this is blank as of now, and using these code, I'll actually start writing files into it. So once I've run this particular code, it is actually creating my scoring script. If you see the scoring script, these are just these 2 functions that we wrote over there. As of now, this is the only file that we have in our folder, and this folder will be actually converted into your container deployment code folder into your container. So anything that you keep over here will actually go and be bundled. So keep this as a minimalistic. Do not actually bundle this with any of the things that is not required in the scoring. For example, any of your say data part which is not required in scoring, do not put into this folder. The second thing that we'll be doing is on the terms of dependencies. So sometime back I told you that Azure ML can deal with both conda dependencies as well as pip dependencies. So it actually, instead of using requirements.txt, which is mostly used for only pip dependencies, it has its own mechanism of defining the environment, which is as simple as, if you have any packages, just tell it what packages that you have, and just realize that packages into a YAML, and that will come as which is similar to very requirements.txt, but a YAML format of requirements.txt. It has 2 types. So one is your conda dependencies and pip dependencies, and also your runtime. which specific Python runtime that you require in this particular case. It have already got like what runtime I'm using my Azure ML on, and to keep everything consistent with that, it has already declared the runtime over here. And I started this with a blank folder, and all these files are created from my driver program. So I'll call this as my driver program, and this is the only thing that you will require. And you can have this driver program directly on your system, on your local systems, and everything that you create over here will be automatically ported. That is what we'll be showing next. So there are different ways of deployment. You can deploy it locally and if you want. And since everything from here, this particular folder would be packaged into a local Docker, and that will be installed onto your local Docker. So if you have a local Docker, you can just start it, and you can have like a local deployment over here. I'm using an ACI web service, which is a Azure Container Instance. So in the same way that the things will run on my local Docker, it will actually be running on the container over there. And because I'm using this Azure ML SDK services, so it will take care that all the dependencies and everything, or the environment is actually consistent across my local Docker versus my Azure container versus Kubernetes pods and everything from there. So instead of using a local Docker, I'm directly using Azure Container Services, which means that the deployment will go on my Azure workspace as a container. Here I've described like what type of container that I want. So I want one CPU and 1 GB of memory over there. In case if you are deploying to Kubernetes or any of the inferencing clusters apart from Kubernetes also, then you can also have a target of deployment to which cluster that you want to deploy. In this particular case, such a single container, so I don't have to give that target in terms of clusters. I can just say the containers. So what this is doing is now it has taken both of these complete folder, which is diabetes services, which has my script, my scoring script, and my environment. So these are the two things that I declare over here. My entries, this is my folder. So first of all, this folder is my diabetes service folder. Deploy this folder onto the container. And once you deploy the folder on the container, this is my entry script that you use for any of the calls that are coming up. And within the script, now there's a two predefined function which is run and init. Use that so that I do not have to mention those run and init. That is understood by Azure ML SDK. And while deploying that particular container on the mini-conda version that you'll be using, please also have these requirements specified into it or installed onto it. And then those requirements I just sklearn that I'm using. That's the only thing that I have put. So now in some time it will be okay. It's already running now, so which means now the container is started. It is not ready for you can say services, but now the container services started coming up, and after some time you'll see it ready. So if you want, you can just run this now. It will show you the state. It might not be healthy state. It might be like starting or initializing. So apart from writing this code, which is like a minimalistic code for deploying it, it hardly takes like 5-10 minutes for it to completely get started as a service as a container. If you're doing something like Kubernetes container, you can actually do two things. The recommended thing is that you actually because Kubernetes is not something that you'll be erecting for a particular just one particular REST service. Maybe even if it's a scaled REST service and you have 20 or 100 different instances of that one particular REST service, maybe Kubernetes might not be the best way to do it. Function might be a better thing, depending on whatever thing is. So Kubernetes cluster is something that you'll have like for a complete namespace, which might belong to a particular department or a complete company. So you can have the Kubernetes cluster ready and point it to that cluster, which is you've registered in the workspace. Or if you want, you can even start a whole new Kubernetes cluster with just one line of. We are not covering the Kubernetes in this particular session, but once you take the workshop, we'll actually cover how do you create a Kubernetes cluster with within your Jupyter notebook itself. That's just one line of code, and I can give that cluster additionally into that deployment configuration. In that particular case, I'll not use the ACI web service, which is for container instance. I'll use the AKS web service, which is for the Kubernetes web service. So I think 5-10 seconds more, and then the services will be up and ready. Now, meanwhile, we can see our Azure workspace, how it is happening. So we saw this particular models and model versions. Let's go to model number 5. That is what we actually run the deployment for. Deployments is again once the models are deployed. Deployment itself is a part of the workspace itself. So I actually do not have to go to individual models to see if they're deployed or not. I can actually go to the deployments. And similarly, I do not have to invoke a particular model within my Jupyter to get the deployment instance of it. I can directly get the deployment instance within the workspace. These are important differences, how machine learning becomes easier for you once you are into a workspace. So you do not have to actually have those IDs being maintained everywhere for each and every model deployment and so on and so forth. In case if you're going for the pre-built managed model, then you give the data and they'll give you model IDs and specific keys for that you have to contain. But in this particular case, once your workspace is authenticated, everything becomes like a high-level part of the workspace. So now I got the succeeded message. So if I check my status now, it will give me a healthy status and it will give me someone can. So now my web service is up and running over there, and I've got a healthy status for this particular web service and all the logs if I want to troubleshoot if it is not healthy. So I'll show two ways how you can invoke these web services, both within the Jupyter. One is, since we actually created that particular web service, we'll get the web service instance, and for that we do not require any of the previous thing except for a web workspace authentication. And as we saw in Azure, deployment is a part of workspace, so irrespective of the deployment, it becomes part of your workspace. So once we have got a service instance from my workspace, I can use the same service instance to score any of the new data. So suppose this is my new data. So this is my BMI and all those things that we showed in terms of features. For a single patient, we actually just use this, convert into JSON, this whole NumPy array into JSON or list into a JSON. And then we call that service.run, which was the run method that we had described in the service with this particular data, and that is given as a prediction. So the patient was this, and this is diabetic. And what is recommended is, as far as possible, try to have patterns within your run such that it can deal with both single response and as well as multiple response. Because once we go into the pipeline side, you will see we can actually use the same run deployment both for REST services and also for putting data into a C. And if you want to do that, the way that we have designed it is that whether it is like one input or multiple inputs, it will actually give responses for each of them. The second way that we are trying to deal it with the batch. So instead of we can, as of now it is a service, so we can give the batch to the service itself. So it has given us responses for both of these things, and are actually responses that are going on the web. So these are not running on my system. These responses are going on the web on that particular Azure Container Instance REST service that is there. You have also can see how it is happening. So that is one way, because I already have my SDK running on my Jupyter and I have the instance of the service, so I do not actually have to get into any of the details of how do I invoke it. Once I've got that service.run is what I require. That is the only thing that I require. But assumingly, you obviously will not run it directly from not only from a Python application. If it is a Python application, you can directly get the service instance within a Python application. But suppose if it is a Java application that requires to run these particular services. Okay, so for example, then you can actually need the URI for that. So it will give me some URI also. And if you see, the moment I run it, it actually changed the URI because it was the previous URI that was there, and it has given me the new URI. And you can use this URI the way that you actually use invoke any of the services, which means using a Python request and JSON. So using Python request, I have created a header. And since in this particular case, I'm using a bias example where my Jupyter is already authenticated, and I made things easier for me because I have not actually using any separate means of authenticating it. My Jupyter authentication has worked in this particular case. So my header only contains what is my application type, which is a JSON. So I just convert my request in the JSON format the way that I had done it earlier. The only difference is, instead of calling service.run, I am assuming that I do not have a service handle with me. The only thing I've got is a URI, which I have embedded into my environment somewhere in my application. And I'm using my request.post, get the responses for it. And with the post, I obviously get the endpoint, which is the URI that we got, this particular URI. My input JSON, which is this data. Okay, and my header which just tells what type of input it is. It's the application JSON input. And when moment I run it, it will actually give me this. Now suppose if it you are using a basic way of authentication, it is not like an SDK way of authentication. Within even it has like SDKs in different other languages also. Even if you're not using SDK, if it is a pure REST service that you want to use, then you can get service.get tokens. It will give you tokens, and then you can embed those tokens within your headers. Okay. Now we'll just walk through to see that particular deployment. So within the deployments, I have this diabetes service, which is now created just now. The one that we actually did, this is UTC timing, and the instant type, if you had observed, it was ACI, which is Azure Container Services. So even if there are other type of deployments directly as a REST or as a local compute within a particular this workspace, you can actually have a local compute and you can have it deployed over there, or you can have Kubernetes. So all the types of deployment will actually come here bundled. and you can see what type of deployment it is. So this, we actually started with 1 GB of RAM and 1 CPU. It is showing me the deployment configuration. I could get the same scoring URI from here. Okay, and if you compare over there, this is the same URI that we are using earlier. Yeah. Okay, so I can use either the portal or my SDK to see, deal, and get data from any of these things. Now, since one work is done, I can either manually delete it from the Azure, or I could actually delete it from here. And the moment the service is deleted, we'll see it's not available over there, and it's not built anymore for this particular application. This is also required for specific instances. So suppose if I have like model 5 and model 4 being deployed simultaneously, although I couldn't do a load balancing on it as a container, I have to get into other load balancers. So in that particular case, Kubernetes might be a better way if I want to do something like an A/B testing. And once my A/B testing is done and I have found that the new version is performing good, that is when I'll actually delete the previous version. And since it's the service class that is given to us, which is common across all the things, and internally it manages the specific, you can say, complexities of all the different environments. So it will take care of if the service is deployed on container, how do you delete that particular Kubernetes, how do you delete that, and so on and so forth. So all these things are again transparent to us, and complexity is set in below. So if you have seen, the whole idea of this familiarization is number one, to make you familiar with Azure portal, the machine learning portal, the workspace, the studio part of it, and also how easy it is to go from any of the work that you do in a non-production environment, maybe even POCs and so on and so forth, and take it to production within some minutes. So I think that was helpful, and we gained something, and now we are excited to actually so get our hands dirty with some of the workshops and advanced sessions that we'll be having on AI product development later. So now I'll actually make it open for any of the questions